So hey guys, it's the day 20 of my doing Leetcode daily until I get a job. So let's start with the questions today. And fine, just 1 second. Yeah, okay. So the first question is, we will be doing these remaining four questions. Four we have done in the greedy approach questions. So first is the hand of straights. Alice has some number of cards and she wants to rearrange the cards into groups so that each group is of size group size and consists of group size consecutive cards. So अगर तीन group size है, if three is the group size, then every group must contain three consecutive cards. Given the array hand where hand I is the value written on the ith card and an integer group size, return true if she can arrange the cards and false otherwise. So if there are n cards and there must be groups of size 3 and each group has three consecutive elements. So basically what does it mean that uh, the number of cards must be divisible by the group size, and if they are not, like just simple, if they are not, we'll just return false, that they cannot be rearranged in size of group sizes, and each consists of group size consecutive cards. So int n is hand dot size. Okay, and if n is not divisible by group size, then we will just return false, right? Now what we can do for rest of the things is that see, we are given this and consecutive must be there, right? So what we can do is we can just sort them out. Okay, sorting them, what will be the answer, what will be the array looks like after sorting? So 1 is coming one time, then 2 and 2, and then 3 and 3, 3 and 3, then 4 and 6, 4, 6, 7 and 8. Okay, so if we say 1 2 3 being the one, so 1 2 3 being the one group, second group can be 2 3 4, 2 3 4, and third group can be 6 7 8. Okay, so what happened here is after sorting it out, we can see we are in a much better position here, so that we can see, we will go to each element and we'll see that can it be the starting of any group. And what's the condition that it can be a starting of any group is that if this is the starting, then there must be group size number of elements in that group. Means next element is, if current element is a, next element is a plus 1, a plus 2, until the size becomes group size. Okay, until the size become 3. Are there enough elements in the hand array that we can form this group? Okay, if we can form this group, now 1 2 3 is done, fine, but will we go to this 2 because this is already considered in a group already? Should we go to this? We should not. So we should do something to say that it's visited, we don't have to visit it again. Okay, so that's what we need to do. So let's just go straight to the code and try to solve this. So we will just sort the array, right? Hand dot begin to hand dot end. Okay, it's sorted now. So we will run a loop for int I 0 to I less than ni plus plus. Okay, we'll go to each of the element and we'll see. What we will see is, if we'll put in this condition that if it's not visited, okay, we'll think about this condition, what this condition should be. So if this condition is true that it is not visited, if it is not visited current node, then can start. Can we start a group from this element? If we can, if we cannot, like if it returns a false, then we will also return a false, that it's not possible to form groups. Otherwise we will just return true. Okay, if we cannot start from here, if we cannot start from here, it is also not included in any of the groups, then what's the point that this element is remaining? So it's false. Okay, so can start, we will send as argument the hand array, the group size, the element we are at I, and we can say you can send in. Okay, and size. Okay, so let's write this function now, that bool can start. It will give us what, that can we start a group starting from this element. Okay, so we will just paste it here. Group size, int I and int n. Fine. Now how do we know that we have to have a group from right from starting from here? See, what we can do is, we have found one element in the group. We will consider that we can start. Okay, let's say that we will do it by prove by, what do we say, that it's not possible. We will take it as true, and then later if it comes out to be false, our thing is proved that we cannot start. Okay, so we will just say that we have found the one element. So what should be the next element is, if our current element is hand I, next element should be hand I plus 1, because they should be consecutive numbers, right? And how many elements we have found? One we have found. If this count becomes equal to group size, then there is a group. Okay, so count is 1. Now we should find a way to do like the, we have visited the current element. So just put it as what's the group, hand I is 0 to 10. Okay, we will just put hand I is equal to -1, and that also gives us the condition we have to write here, that if hand I is greater or equal to 0, then only we have to go in this if condition. Otherwise, if it's negative, it means it's already visited, we don't have to visit it again, because if it is visited, then it must be already in some group, and if it's not in that group and it's visited, that means the group was not formed. It will return false here, and we will just go out of the code. Okay, so hand I is -1. So, and we are at the next element now. So while I is less than n, okay, that's the basic condition, that we should not go out of the bounds of the array, and count is less than group size. Count is still not equal to group size. What we need to do, we need to check if hand I, we have incremented I already, just look at this. Okay, if it is equal to next, that means we have found that element. Okay, next element is also present, then we will do this, next is equal to +1, or we can say hand I plus 1. We will increment the count, that we have found one more element. Fine. And what else we can do is we will current node will be visited. Okay, I'll put this as -1 and increment the I. So if the count is equal to the group size, then we will return true. So count is equal to group size. Okay, if it is, then it will return true. If it return true, it will won't go into this condition, it won't return false. Fine, so this should do the thing. Yes, let's try submitting it. Yeah, okay, fine. Next question is the merge triplet to form the target. So a triplet is an array of 3 integer. You have given a 2D integer array triplets, where triplet I is AI, BI, CI, depends, describes the ith triplet. You are also given a integer array target, means the target triplet, that describes the triplet you want to obtain. So to obtain this target, you may apply the following operation on triplets any number of times. So choose the two indices I and j, okay, and update triplet j to become max of aiej, max of bibj, max of cicj. Okay. For example, if triplet I is this, triplet j is this. So after like applying this operation on these two triplets, the resulting triplet will be max of 2 and 1, max of 5 and 7, max of 3 and 5. So it will be 275. It is equal to, if it this is equal to the target, then we will just return true. Okay, means return true if it's possible to obtain the target triplet as an element of triplets, or false otherwise. If we cannot, just return false. So what we can do here basically is, see, that seems to be a easy one. And how can we do this is, we are given this. Okay, so what we can do here is we can go one by one to each triplet. Let's say first we will go here and we will see, is any of the element of this triplet is corresponding element of this triplet is equal to the corresponding element of target. Like, is the first element of this triplet equal to the first element of target? If we see that yes it is, then we have found one element of the triplet. Then what we need to see, if the rest of the two elements should be less or equal to the target's next two elements. Are they? Yes, 5 is less than 7, 3 is less than 5. Why we are checking this is because see, if in some other triplet we find the second element of that triplet equal to the target second element, then we will apply that operation to these two triplet, right? We can apply the operation to these two triplet, which will give us what result, that yeah, 2 is greater than 1, so 2 will be first element. 5 is less than 7, so 7 will be the second element. So we have matched the two elements. So we'll just keep a track of how many elements we have matched. We have, let's say, for three elements we will take three boolean values. Okay, and every time one value we have found, we will just do a is true now. Then if we found b also, and b also obeys the same condition, that second element is equal to the second element of target, and rest of the two elements are less than equal to target, less or equal to. So 1 is less than 2 and 5 is less or equal to 5, so that is true. Now uh, we will apply and now the third element is also equal to the target's third element. Are the rest of the two elements less or equal to the target's rest of the two elements? Yes, they are. 7 is equal to 7 and 2 is greater than 1, so that's fine. So this is how we can do it. And yeah, we can take three boolean values: bool a, which is initially false, b false, c false. Fine. And we will just go each element of the triplet. So we will just do this auto c of auto element of this triplets. What we need to do, if element 0 if element 0 is equal to target 0, okay, target 0, and rest of the two elements means le1 should be less or equal to target 1 and le2 must be less or equal to target 2. If this is the case, we have found one element, so a will be equal to true now. Okay, same condition we can apply for rest of the two positions, that is option 1. Okay, option 1 will be there and it will be 0 and 0 and 2 and 2. Okay, and it should be 1 and 2, so we will just 0 and 2 are here, 1 and 2 are here, so it will be 0 and 1. So control X, What happened? Okay, it should be 1 0, it should be okay, fine. So control X, I did control Z actually. So control X V, and we will put take this and put out here, then move this, and we will do this less or equal to yes, fine. If this is true, then B will be equal to true, and if this is true, C will be equal to true, and we will return when A, B and C all are true. Means A is equal to true and B. Oh, okay, we can do just do that. A and B and C. Okay, we can just return this. Let's run. Yes. Okay. So yeah, 58 out of 60 pass. 131 in this case. Um, 132 target. 131 is this. It should be returning false. Why is it returning true? Okay. Fine. There should be two equals. Yes. Yeah, fine. Next is the partition labels. You are given a string S. We want to partition the string into as many parts as possible so as each letter appears in at most one part. Okay. Note that the partition is done so far after concatenating all parts in order. Resulting string should be S. Okay, we do not have to, we cannot change the position of any of the character because while concatenating the partitions, the string must be same as the initial string. Return a list of integers representing the size of each part. Okay, so if this is the string, and we have to partition it in such a way that in one partition, if an element appears, it should not appear in any of the other partitions. See, what we can do here is, so basically what is given to us is that if A appears in one partition, then A should not appear in any other partition. All A's are should be in single partition only. So if this A is here, okay, let's consider this as the first partition. If this A is here, then all the A should be in first partition. So what is the last occurrence of A? There is a, there is a, there is a, and means this is the last occurrence. Okay, so we will consider for now this is the first partition, but the condition is that every element in this partition should also be following this thing, that all the occurrences of B should be in this partition only. So is there any other partition of B outside of this partition? No. Is there any C? No. Okay, yeah, fine. So we are good with this. We have found the one partition. Its size is 3369. Okay, 9 is this size. Then we will now start checking from here. So how will we do this is that we will take, we will store them in a map, and in the map we will store it like character as the key and its last occurring index as its value. Okay, so uh, we will firstly take the partition size as what is the last occurring index of A. This will be our partition size. Fine. Then we will see B. If B's occurrence is less than this partition size, then that's fine. If B's occurrence is out of that partition size, let's say B existed here in place of E, then that partition would have been up to here. If we reach up to here, okay, then we will see for again A is there, B, C. Similarly we'll do. Okay, if let's just say that this was a B here, then the partition was up to here. Then up to here there is no problem. When we reach D, we will see that is there any other occurrence of D. Yeah, there is this. So we will extend this partition to here because we have no other choice. Okay, we have no other choice. Then we will check B. No B is there out outside this. If is F is there, no F is there. If E is there, no E is there. Is G there? No G is there. Is D there? No D is there. Is E there? No E is outside. So this will have been the one partition and rest will have been the second. Like we will just similarly find other partitions. So this is how we would have worked with it. So let's just try to do this because that's not seems to be a really tough question. So we'll take a map, unordered map, and that will be character to int. Let's just say this MP, and for char C in the string S, what we can do is MP. Okay, we have to find the index, so I have to do it this way. Now the choice I less than s dot size I plus plus. Okay, and MP of si is equal to I. That will give us the save the last occurrence of any character in the string. Fine. Now partition size. Okay, let's take a vector which we need to return, which will contain the partition sizes. Okay, vector int answer, and yeah, let's start iterating the string now. Int I 0 to I less than s dot size I plus plus. So max partition, let's take a variable max partition which is equal to -1 initially, and max partition will be equal to max of max partition comma mp of si. I think you understand that, right? That max partition will be equal to what? For currently it will be equal to map of a. Okay, map of a is this ninth index. Fine. So if we are iterating through all of the elements in between this index max partition and this, and we have found nothing which is crossing this max partition, then we will do what? If we reaches that max partition, that means we have got a partition. There is nothing in between which is extending the partition. Okay, we have found the end of the partition. If I is equal to max partition, that means we have got one partition. Okay, so we will just answer dot push back max partition. Okay, max partition, and we will make this again to 0 because again we have to start this and size should be again starting from 0. But next thing should be 7, and max partition must be equal to 0. I think it should work. Yes, I guess. Let's see. Okay, it is given 8, 15, 23. 8, 15, 23. Okay, this is fine. That this is 0 to 8, 9 elements. 8 to 15, 17 elements, and 23 minus 15, 8 elements. So what should we do is I is equal to max partition. Okay, I got it. I got it. I got it. I got it. Um, let's take a variable which is showcasing us what was the start of this partition. Yeah, which is showing, which is signifying the start of this partition. So minus start. Okay. Yeah, minus start is fine, but should we do it plus one? Should we do a plus one? Again, the pre will be equal to max partition, and let's say we do this. Okay, it's giving 8, 9, 8, 9, so it's incrementing one value. Okay, so how much time we have done? 26 minutes. Fine, 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 fine. Okay, yeah. So what if we do it minus? We should remove that obviously. Max partition. Okay, obviously max partition not needs to be 0 because we are obviously minusing the start. Ah, if we do it minus 1, then on the initial phase it will do what? Max partition 8 minus minus 1 9. Then the start is 8 now. When 15, 15 minus 8, yeah, that should work. Okay, let's try submitting it. Fine. Now is the last question. Given a string as containing only three types of characters, opening round parenthesis, closing round parenthesis and a star, return true if as is valid. वैलिड होने के लिए रूल ये है कि there must be a, for an any opening there must be a closing, for any closing there must be an opening, and if left parenthesis must go before the right parenthesis, opening must be before closing. Star can be treated as either an opening bracket or a closing bracket or an empty string. So it can compensate one error. Okay, if there is one error in our input, it can compensate that. So single, okay, fine. So what we can do is, let's just say we have this, then not a problem at all. Okay. See, everything depends on the opening ones. On the closing ones, let's say we take a count left and we increment it every time whenever we get a opening bracket. Okay, we got a opening bracket, left will be 1, then 2, then we got a closing, we will increment 1, again it will be 1, and again we got a closing, we'll decrement again. If left is equal to 0, then we have a valid one. But what if we get a star here, like this and then this? So here we have to consider this star as a closing one, but maybe this happens, or maybe this happens, that we have to consider it as an opening. So if we are considering only left, let's just say that we take two things, a and b, two variables, and it will show the number of left like opening brackets, maximum number of opening brackets. and it will show us the minimum number of opening brackets. Minimum and maximum signify what is that. Minimum will be whenever we can encounter a star, we will count it as a closing, and maximum of the left shows whenever we get a star, we will consider it as a opening bracket. Okay, so A is, so let's say L max and L min, two variable are there. Okay, now in this case we get a opening, both are incremented. Now we get a star. Max will consider this as an opening, so it will be 2 now, and this will consider this as a closing, so it will be 0 now. Now next is closing, so -1. Again next is closing, -1. So let's just say for this one, okay. If left is closing, and at any moment, if we get a closing, and at any moment after this, if L min becomes a negative number, L min at any moment, if it is less than 0, and this L max is not less than 0, L max is not less than 0. Okay, if this is the case, that means that we have just got L min, and we have encountered a star and we treated it wrong way. Okay, then we will just do what? We will put the L min as 0 and go forward. Again we get a closing bracket. Okay, again it was 0 now, so again it's -1, and it was 1, so 1 minus 1 0. It now becomes 0 and it is again -1. So we'll check if L max is 0, less than 0. It's not, but L min is less than 0, so we'll put L min as 0, and we will return what? That if L min is 0 or not. If it is 0, then true. If it's not, then false. So that can be the working solution. So let's just try it. So we are taking two variables, L min 0, L max 0 for auto C, or we can say just char C of this string. If C is equal to opening bracket, then we will do what? L min plus plus and L max plus plus. Fine. Else if C is equal to closing round bracket, then L min minus minus, L max minus minus. And if we get anything else apart from that, that must be only star, because that's the only these three are the only possible characters in the string. If that is the case, then L min will be minus minus. It will consider it as a closing bracket, and L max will consider this as a opening bracket. So after this, all this, if L max is less than 0, even after considering even star as opening, if still L max is less than 0, then we will just return false, that it's not a valid one. And if L max is not negative but L min is less than 0, we'll just put this. Okay, we'll rectify our mistake that it should have been a opening one, and we will just return L min is equal to 0. Fine. Okay, it should be C, not S. Fine. Perfect. Yeah, so these are the 4 questions. Really easy, not much to do in those questions, and we are done with the greedy also. So I don't know how many questions we have done in this Leetcode series, but yeah, we have done a lot of series, a lot of like sets of question, I must say. We have done arrays, hashing, two pointers, stack, binary search, sliding window, then trees, then graphs, then 1 DDP, then intervals, and then now greedy is also done. So tomorrow we can start with like we can for now we can just start with some interview specific questions. Okay, we have done enough that we have the basic understanding now how we have to do. So from tomorrow I will try to come up with a sheet interview specific questions. So yeah, we can try the strivers also. Striver SD sheet, maybe that could help. How many questions are there depends on that. Okay, so there are a lot of questions. 191, no, 191, there are a lot. We should start with the smaller sheet. It's a blind 75. That's a famous one. I think most of the questions are same, but how to close this? Yeah, I think most of the questions are same that we have already done, but we will, if they are same, we will just skip them. If they are not, we will do them, and we will try to complete this within 2 to 3 days. Okay, because they are really basic questions, I guess. Like heap, we have not done, so that will be good for us. That's another thing that there are only two questions there. But yeah, we can do matrix, linked list, graph, dynamic programming, 11 questions. That will help because we haven't done this much. Yeah, house robber, obviously, decode ways, we have done word break, we have done coin change, we have done climax stairs, we have done grid unique path, jump gear, we have done. So most of them we have done. Whatever we have not, we will just do them. Not to worry. Fine. Yeah, we can start with it tomorrow and try to complete it as soon as possible. So yeah, this will be it for today. And yeah, we are well on time. We're only 30 minutes in this four question. Those medium questions. So yeah, that's good. Okay, we'll meet on day 22.